Hello friends, we are studying one more interesting topic in this video. We'll discuss about division operations in binary numbers. Basically, to divide any two binary numbers, we have two different methods. Two different important methods, I will say. Number one is restoring method and number two is non-restoring method. In today's lecture, we'll cover both the methods. We'll see how to divide two binary numbers using both the cases. One is using restoring method and the second one is using non-restoring method. So I hope this video will be very interesting for you. Let's start the video. Hello everyone, we are studying one more important topic in COA, which is about division of two binary numbers. So we'll start the video. We'll see how to divide two binary numbers with the help of some algorithms. So if you remember, we have already discussed the traditional division technique for any two binary numbers, which is exactly same with your decimal division. If you want to revise the video or if you want to watch the video, please refer to my previous videos where we have discussed about how to divide two binary numbers using traditional approach, right? Now this approach, the same approach, we cannot directly tell our computer to divide like this. For that we have some algorithms, right? Just like for multiplication algorithms, we have two algorithms we have seen in the last videos. So for division also we have two different algorithms. So any one of the algorithms you can use, both the algorithm works perfectly fine. For signed and unsigned, for both the numbers you can use the technique. So the first algorithm is known as restored algorithm or restoring algorithm. So if you see the flow chart, I think it will be very difficult for you to understand. So better I will take one example and I will explain how restoring technique works. And then we'll go for other technique. So let's discuss about the division of two binary numbers using restoring method. See the flow chart, what we have. Before the flow chart, say I have dividend as 7, divisor as 3. Q is dividend and divisor is 3. So you have to be careful while selecting these variables. Every time you have to select dividend in Q and divisor in M. Unlike your multiplication, here you cannot exchange the variables. In multiplication, A into B and B into A is same. So it does not matter which one is Q and which one is M. But for division, it matters a lot. So Q is Q, you cannot change with M. Fine. So I have 7 and 3. So I will do 7 divided by 3. Just convert these numbers to binary 0111 and 0011. And somewhere you note down minus M also, because in our algorithm we need minus M to use. So if this is M, this is minus M. So now what is the shortcut way to get minus M directly from M? I have already discussed in video number 2. Please go back and watch the video if you don't know how to convert from M to minus M, any binary number to 2's complement without using any formula. It's a trick I have given in that video. So now we are ready to follow the algorithm. So just like our previous algorithms, we will start with this box. What we have? A equals to 0. So A, I am putting 4 zeros. Why 4 zeros? You already know, because in the previous lecture we said, because we have 4 bits. Then we have M, Q and count. So Q I am putting here 0111, M is 0011 and count is 4 because 4 bits. So first step is very simple. This is the initial phase. Next what I will do, I will come this box. If you see here, without any condition, once the initialization is done, I have to immediately shift left, not right. In multiplication we have done right shift, here left shift. Without any condition, I have to shift left. What I have to shift left? A and Q. One bit I have to shift from Q to A, left side, not right side. Do it, we have to do it. So this one will come here, this one will come here, this one will come here, this 0 is coming here, this 0 is here, this 0 is here, this 0 is. So this 0 will be eliminating because there is no space. Fine. Now in multiplication what we did, the empty space we have filled with zeros for unsigned, and for signed we have seen the MSB, and based on MSB we have filled either with 0 or 1, right? But for division, just keep it empty, don't put 0 or 1. It depends on the next steps. So please keep it empty. So the last digit is empty because I don't have anything here. Keep it empty only. M, whatever M you have, and count whatever count you have. Fine. So shifting is done, then I will come here. Now here also without any condition I have to perform this operation every time. What is that? A equals to A minus M. What is my A? 0, 0, 0, 0. What is my minus M? Here I have noted down somewhere 1, 1, 0, 1. So 1, 1, 0, 1. If you do the addition, what you will get? 1, 0, 1, 1. So this part is done. So after addition, immediately I have a conditional statement here now. What I have to check whether my A is less than 0 or not, means whether my A is negative or not. Less than 0 means negative. Check my A. What is my A? This is the A, 1101, right? This is the updated A after performing A equals to A minus M. Whether this A is negative or not. How you will say whether it's a negative or not? By seeing the first bit, you can say, right? If it is 1, then negative. If it is 0, it's positive. We have already discussed these things in the previous videos. So by seeing this one, we can say, yeah, A is negative. If it is negative, I will go this side. Yes, this is negative or less than 0, so I will come this side. So this side what I have, Q naught equals to 0. So Q naught, which was empty before, I will fill it with 0. Now it's filled with 0. Now I can fill it. Understood that? If it is not negative or positive number, then Q naught will be 1. So it depends on this condition. That's why I told you, don't put anything immediately. So we'll have to follow the next step. Fine. So I put 0 here, and whatever I have given like that. 4 I have, so I have given like that. So after that, this is not the end. I have to perform again A equals to A plus M. Fine. What is my A? 1101. Fine. What is my M? Check it. 0011. So just add it. 11 is 0. So you have a carry out bit. 11 is 0. You have a carry out bit. 0. 11 is 0. So I am getting 0000. Here I have 1110. Here I have 0011. Then I am putting count equals to count minus 1, which is 3. Fine. So this step is done. Then we'll go for the count equals to 0 or not condition. Now just note it here. Why this method is called restoring method? Every time we are restoring the values for A. That's why we call it as a restoring method. How? See here carefully, logically. Forget about the algorithms or these steps for 1 or 2 minutes. Think logically. What I am doing here? A equals to A minus M. And what I am doing here? A equals to A plus M. What I am doing here? I am doing A equals to A minus M. Here I am doing A equals to A plus M. So indirectly I am restoring the previous value only. What I am getting as a new value? 0000, which was my previous value only. I am restoring back. I am restoring my previous A only. That's why this method is called restoring method. Okay, we'll move on with the algorithm now. So this page is done. I hope this is clear for you. Next, we'll go for the next run because this is not count, is not 0. So once I am here, what I'll do? Without any condition, I have to shift left, A and Q, do it. So how to do that? This is my Q, this is my A. So this 0 will be coming here, 1 is here, 1 is here. This 1 is coming here, 0 is here, 0 is here, 0 is here. This 0 will be eliminated. And as I told you in the previous step, this is empty initially. Don't put anything. Whatever M I have, put it. Whatever count I have, just put it as it is. Fine. So after that, what I have to do here is A equals to A minus M. Do it. What is my A? After left shift, what is my A? 0001. What is my minus M? 1101. So just add these two. 11 is 0, 1, 1, 1. So this is the updated value you got. Now you check whether this is less than 0 or not. Again, this is less than 0 or negative because this bit is 1 or the MSB is 1. So if it is yes, then I will go back to right hand side and I will put 0 in Q naught. So I am putting 1 0 here in the empty space. Rest all the things are same. Fine. After that, what I have to do? Again, I have to do A equals to A plus M. Do it. What is my current A now? The current A is 1110. And what is my M? M is 0011. Just add it. 01 is 1, 11 is 0. You have a carry out bit. So 11 is 0, 11 is 0. 0, 0, 0, 1. And this one is 1, 1, 0, 0. This one is 0, 0, 1, 1. And count equals to count minus 1. So I have 2 here. So here also I am getting the previous A only. Check it. 0, 0, 0, 1 I am getting. So previously I have 0, 0, 0, 1 here also. So I am restoring it back. That's why this method is restoring. So whether my count is 0? No, this is 2. So go back to this step again and do the left shifting. If you do so, what you will have? This 0 will be coming here, this 0 is here, this 1 is here, this 1 is here, this 1 is here, this 0 is here, this 0 is here. Fine. Now what is my A? Yeah, sorry. This empty space, you keep it as it is. You whatever M you have, keep it as it is. Whatever count you have, put it as it is. So after left shifting, do A equals to A minus M. So what is my A? 0011. What is my minus M? 1101. Just add it. 11 is 0. So you have a carry out bit. So 11 is 0, 11 is 0, 11 is 0. Now whether this is less than 0 or negative number? No. Now the MSB is 0. Right? If it is 0, what I will do? I will put 1 in Q naught. Now this is 1. Why? This is not a negative number. So I have 1 here. Whatever m I had, I put as it is, and count equals to count minus 1 is 1. Because if I am in left hand side only, I have to put q naught equals to 1. I don't have any arithmetic like right hand side. Here I have a equals to a plus m, but here I don't have anything. So simply just put 1 in q naught and then count equals to count minus 1. That's it. Still my count is not 0, right? So again I will go back here and do the left shift. So if you do so, what you will have? This 1 will be coming here, this 0 will be coming here, this 0 is here, this 1 is here, this 0 is here, 0 is here, 0 is here. Keep it empty. Whatever m you have, you put it. Whatever count you have, put it. Then I will do a equals to a minus 1, right? What is my a? 0, 0, 0, 1. What is my m? Minus m? 1, 1, 0, 1. Do it. Add it. 1, 1 is 0. So carry out bit is 1. So 1, 1, 1. So 1, 1, 1, 0. So 1, 1, 1, 0 is negative or positive? Negative. So I will come this side and q naught will be 0. So I am putting 0 here. Fine. Rest all the things are same. Then what I am doing? A equals to a plus 1. What is my m? So what is my a? 1, 1, 1, 0. What is my m? 0, 0, 1, 1. Just add it. 0, 1 is 1, 1, 1 is 0. You have a carry out bit. So 1, 1 is 0, 1, 1 is 0. Fine. This is whatever I have. This is also whatever I have. And count equals to count minus 1, which is 0 now. I hope you understood that. So after getting count equals to 0, we are end of the algorithm. So once we are end of the algorithm, the final result is like this. The quotient q is in q, which is 0, 0, sorry, which is, where is q? Here, 0, 0, 1, 0, which is 2, right? If you convert back to decimal, you will get 2. Then what is the remainder? Remainder is stored in a. Whatever a you are getting, that is nothing but remainder, 0, 0, 0, 1, which is 1 in decimal. So this is the correct result, right? If you do 7 divided by 3, what is the quotient you will get? 2, right? 2 times 3 into 2 is 6. So that's why 2 I am getting. What is the remainder? You will get 1. So this is the remainder. So I hope you understood this algorithm and why this algorithm called restoring. After practicing 2-3 more examples, it will be more clear to you. So we have one more method called non-restoring division. Now both the algorithm works for all the numbers, so you can choose any one. In exam sometimes they mention using non-restoring or restoring. Otherwise you can follow any one. Now non-restoring comparatively a bigger algorithm, the algorithm is bigger than the restoring. So again with the help of one example we will see how to do that. Fine. Check it what I am taking. So here I am taking q as 0, 111, which is 7, and m as 0, 0, 1, 1, which is 3. Again I am doing 7 divided by 3, same example using non-restoring. So check it what I have to do. I have an initialization box where a equals to 0, putting all 4 zeros, fine. M is divisor, 0, 0, 1, 1. Q is dividend, 0, 111. Then minus m I am writing here only. You can note it down some other place also. What will be the minus 1? If this is m, this is minus m. Again, how to get this minus m means so easily. We have already discussed in our video number 2. Please go back and watch it. And then count is equals to 4 because we are dealing with 4 bits. Initialization is done. Then immediately you have to come here. So you see, after initialization, immediately we have a conditional statement. What is that? Whether my a is less than 0, whether my a is negative or not. What is my a? 0, 0, 0, 0. It's not a negative number. If not, then what I will do? I will come this side. If no, I will come right hand side, right? This is not a negative number. And what I will do? Shift left a and q. So do the left shifting of a and q. So this one will be coming here, this one will be coming here, this one will be coming here, this 0 is here, this 0 is here, 0 is here, 0 is here, this 0 will be eliminated. Just doing the left shift like our previous algorithm. And this is one empty space which we will keep empty as of now. Right? Whatever m, minus m and count I have just written. So after shifting, what I have to do? A equals to a minus m. What is my current a? 0, 0, 0, 0. What is my minus m? 1, 1, 0, 1. So if you do a equals to a minus m, what you will get? 0, 0, 0, 0 plus 1, 1, 0, 1 is nothing but 1, 1, 0, 1 only. Fine. Rest all the things are same. 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 1, 4, everything is same. So after that, what I will do? I will come here. Again, I have one more conditional statement. Whether my a is less than 0 or not. Again, I have to check. So after doing that, whether my a is negative or not. Yes, this is negative because the MSB is 1 here. If yes, what I will do? This q naught is 0. This is negative, so the empty place which I have here, we'll put 1 0 here. Fine, this is 1 1 0 1, this is 1 1 1 0. So after that, what I will do, count equals to count minus 1. So it's 3. Everything is same here. It's 3. So whether count equals to 0, it's not. So I'll go back to this step again. So stage 1 is done. So in stage 2, what I'll check? Immediately I'll check whether my A is negative or positive. What is my A? 1 1 0 1, which is negative, right? This is 1. So if it is negative, so I'll come this side, and what I'll do, shift left AQ. Shift left AQ is common for both the sides. So no matter what, you have to do shift left AQ. Then only the next step is different. Here A equals to A minus M, here A equals to A plus M. So do it. Shift left side of A and Q. This is my Q. So this, so what I will have, this 0 will be here, this 1 is here, this 1 is here, this 1 is here, this 1 is here, this 0 is here, this 1 is here. So I have one empty space here. I have only 3 bits, right? Keep it as it is. Whatever value I have in M minus M, and count I have as it is. So next what I have to do, after shifting I have to perform A equals to A plus M. Fine, I have to perform A equals to A plus M. What is my A? 1 0 1 1. What is my M? 0 0 1 1. You just add these two. Now I am not explaining how to add these two numbers. Now you are expert enough to do that. So if you add these two, you will get 1 1 1 0 only. Do it and see. And then I will go for this one. I will check whether the current A, whatever after performing addition or subtraction, whatever I have done, whether it's negative or positive. It's negative again because I have 1 here. If it is negative, then I will come this side and Q0 will be 0. So again, my Q0 is 0 here. The empty space is filled with 0. Rest all are same, and count equals to count minus 2 is doing here. I will come back here again, and then again I will do what? I will check whether my A is negative or not. Yeah, this is again negative only because I have 1 here. If it is negative, I will come here, do left shift, A equals to A plus M, do it. Left shift means what? This 0 will come here, this 0 is here, this 1 is here, this 1 is here, this 0 is here, 1 is here, 1 is here. This is empty, this is same, whatever I have. Then A equals to A plus M, A is 1 1 0 1, M is 0 0 1. Just add these two, you will get 0 0 0 0. Try it. Just add, because we don't have any carry out bit to store, right? So you have to ignore the carry out bit. So if it is 0 0 0 0, this is not a negative number anymore. If this is not negative number, then Q0 will be 1. So for the first time I am getting 1 in Q0 here. The empty space is filled with 1. Rest all the things are same, and count equals to count minus 1 is 1. I hope this is clear. Fine, it's not 0, so again I will come back here and check whether my A is less than 0 or not. So what? This is not less than 0 now. This is not negative number. If no, then I will come this side and do the left shift. Do it. What you will get? This 1 is here, 0 is here, this 0 is here, this 1 is here, this 0 is here, this 0 is here, this 0 is here. This is empty. Whatever I have in M and minus M and count, I put as it is. Fine. After that, what I will say? After doing the left shift, we'll do A equals to A minus M. What is my A? 0 0. So after left shifting, this is the number we got, 0 0 0 0 1 0 0 1. Sorry, here, right? We are here 1 1 0 1 1 0 0 0 0 1 1 1 1 0 1 and 2 we have. Now what I have to do? We have to check whether this is a negative or positive number, right? We have to check it here. This is a negative number, so I will come here. Why this is negative number? This is 1. So come back here, do left shift and A equals to A minus M, you will get this thing. So I am not explaining why. Again, what I will check whether my A is negative or positive. This is not negative number, no. So Q0 will be 1. That's why this is 1 here. This empty space is filled with 1. And rest all the parts you know. So I hope you know how to do the next step also, right? So once you are done with count, means your count is 0. So this is not the end. We have some other things also to check. It's not like our multiplication algorithm or other rest string algorithm. So once your count is 0, finally I have to check whether my A is less than 0 or not, whether my A is positive or negative. The final A when my count is 0. What is my final A? 1 1 1 0, which is a negative number, right? By seeing this bit we can say. If it is less than 0 or negative, what I will do? Again I have to do A equals to A plus M once again. If it is negative. If it is positive, don't do anything. End of the algorithm. So this is negative, we will perform A equals to A plus M. What is M? A 1 1 1 0. What is M? 0 0 1 1. Just add these two numbers, you will get 0 0 0 1. Whatever q you have, just put as it is, m as it is, minus m also as it is. Now what is the final result? The quotient q is 0 0 1 0 and the remainder a is 0 0 1, which is 2 and 1. This is how non-rastering algorithm works. I hope it's clear for you. Please practice some more examples and let me know if there is any difficulties. Thank you for watching my video.